Number 13 and 5.6 has asked us to use the process of substitution to rewrite this antiderivative in terms of u. And they give us the u, so that, I guess, to make it easier. So we use this u, and the first thing we need to know is if u is equal to x squared plus 2x, what is du equal to? So if u is equal to x squared plus 2x, du is then equal to the derivative of this, 2x plus 2 dx. Okay, now that we have u and du determined, we see right here is our u. So if I switch colors, no, that's not much of a change. This is our u. We're going to need to rewrite dx in terms of du. So we're going to solve here for dx by dividing through by 2x plus 2. So what we're left with is du divided by 2x plus 2 is equal to dx. And this 2x plus 2 does not look like this x plus 1, so I'm going to do a little algebra manipulation to make it look like that so that I can have some factoring. And you'll see what I mean in a second. So I'm going to factor a 2 out of each one of these terms. So I end up with a 1/2 times du over x plus 1. And now I can substitute in our dx value and replace x squared plus 2x with our u. And let's do this over here. So the integral now is x plus 1 divided by u cubed times 1/2 du divided by x plus 1. And if you notice, we have an x plus 1 in the denominator and a factor of x plus 1 in the numerator, so we can factor those. And we're left with 1s there. We have this 1/2 that we can bring out of the antiderivative because it is a constant. So we have 1/2 times the antiderivative of 1 over u cubed du, which I like to rewrite using power function form. So u to the negative 3 du. And now we take the antiderivative. Excuse me. So we're left with 1/2 u to the negative 3 plus 1, which is negative 2 divided by negative 2 plus c. Okay? So now we have a negative 1/4 times 1 over u squared plus c. But we don't really care about u. We want to resubstitute in for u, which we said here was x squared plus 2x. So we have a negative 1 over 4 times x squared plus 2x squared, that's all in the denominator, plus c is our antiderivative.